So now in recent videos we've been looking at the 2N3906. It's actually a PNP bipolar junction transistor, that's what I should say. Part number doesn't really matter. You can use pretty much any PNP bipolar junction transistor in the circuit. But in any case, we're using the 2N3906. We looked at making it a current source before, where we give a adjustable voltage to the base recently. But in any case, that voltage basically transfers across the emitter resistor here. You lose about 0.6 volts, so, and thus it sets the current. We're going to use the zener diode here. You use a reverse bias. Remember, the cathode goes more positive, anode more negative, right there. If you put it in backwards, it conducts like a regular diode. A lot more voltage will get through. It only drop about 0.6 volts. But in any case, we got it reverse bias right there. Cathode is the black band. You can see it's headed to the positive supply. So what that means is in relationship, because we're going to get the full supply voltage basically headed this way. It will drop though when we get to the emitter to base. But in any case, we also got 5.6 volts coming this way, and then current will bring it to ground. That's actually what pulls it below the supply voltage. So 5.6 volts will get through, and the remaining voltage will drop to ground, holding 5.6 volts there. So that's 5.6 volts less than the supply voltage at that point over there. And so takes about 0.6 volts before it starts conducting. We can expect 5 volts lower than the supply voltage there. So in any case, there's 5 volts across the 500 ohm resistor. We can expect 10 milliamps of current. So the transistor will let 10 milliamps of current flow through. That's with no load. And also we can put LEDs in the way. A load, it'll still be 10 milliamps. So now I have the power supply set to 9 volts. It is on right there. We have to bridge the gap through the meter to measure the current that we're going to get. So we're coming to the collector there, and down there you can see we're just shy of 10 milliamps. That's because I'm actually using a 510 ohm resistor instead of a 500 ohm resistor, but it's close enough to 10 milliamps. And there you can see red LED. It's practically the same current. It may be slightly different, and also it'll go up a little bit more as the transistor heats up. But we're going to kind of rush through this because we looked at similar circuits before. So in any case, there you can see the same current right there. Now what we're going to do is we got a blue LED. We can, let's just do 13 right there. And we could go higher than 13 with blue LED, but I think we're going to measure it again with without the blue LED. So we don't want to go any higher than 13. So I'm going to put the two LEDs in series, so we're dropping a lot more voltage right there, but current is holding steady. We can get rid of the red LED, just do the blue LED, and we can either remove the blue LED or just short back here. But you can see the current stays the same, whether we go through the blue LED or not. So, of course, it changes slightly with heat and stuff. But for the most part, we're getting a steady amount of current. Make sure you turn the meter off when you're done. So, that's it for this video. It's the quick video series, and most of this other stuff that you may think could be covered, I covered in earlier videos probably, or I will in future videos. So, hope you enjoy. Make sure you check out one of the other videos I posted on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.